Hello everyone, I Dr. Kirti Sahu welcome you all to this learning video on integral calculus. So here in this video lecture, we shall discuss the MCQs on various topics such as gamma function, beta function and differentiation under integral sign. So let's see the possible questions to be set on these different topics. So the first question is, the value of integral 0 to pi by 6 of cos to the power 4 3 theta sine cube 6 theta integration with respect to theta is. So if you remember, if as the topic is mentioned here that we are going to cover beta, gamma and the differentiation integral under integral sign. So we have to solve these integrals with the help of these tools only, right? Even if you may find the answer of such type of question with certain different tools also, but you have to obtain the answer with the help of these tools only is expected over here, right? But as this being a MCQ type questions, so even if you will apply some other tools, right, and will obtain the answer, then that is also permissible because it is a MCQ type question. So you don't have to present how you get the answer, right? So here, but here as I am explaining how do we get the answer, so I will show you how to get the value of this integral using the beta and gamma function. Okay, so let's see. So if you remember, we have one result of beta function which relates the trigonometric functions, that is cos and sine. What is that result? So beta of mn is nothing but equal to what we have, 2 times integral 0 to pi by 2 of sine to the power 2m minus 1 theta and cos to the power 2n minus 1 theta. This is what we have, and further by using the relation between beta and gamma function, this will take the form, another form. So what is that which we use as a formula? So what is that? That integral from 0 to pi by 2 of sine to the power p theta cos to the power q theta d theta is equal to what? It is equal to, so it is sine to the power p theta cos to the power q theta d theta is equal to what we have? We have this as gamma of p plus 1 by 2 and gamma into gamma q plus 1 by 2 upon 2 times gamma of p plus q plus 2 by 2, right? So this is the formula we will use whenever we have to evaluate integral of such type, right? So here make sure that the variable of integration is theta, then angle over here in sine and cosine must be theta and limit must be 0 to pi by 2. But such type of things we are not observing here. The variable of integration is theta, but the angle over here for sine and cosine is different than theta, as well as the limit is other than pi by 2. So we have to convert this in this form so that we can apply this formula. So how do we do this? So for this, let's take the substitution. What, as we want this as completely theta, so let's make one new angle, introduce one new angle. So we will take 3 theta is equal to what? 5, right? So here we will take 3 theta is equal to 5. So 3 theta is equal to 5. It means theta is 5 by 3. Okay. So differentiate this. So differentiation of theta is equal to 1 by 3 times differentiation with respect to 5. So what we get? So therefore, there will be a change in limits. What will be change in limits? When theta is 0, at that time phi is 0, and when theta is taking the value pi by 6, so phi must be equal to 3 times pi by 6, that is what? Pi by 2. That's how we get the limits as per the requirement. Okay, so this integral will now become integral. So if I denote this integral, say by I, okay, so what it becomes? So I is equal to, we have integration from 0 to pi by 2 of cos 3 theta is 5, so cos phi and limit to the power 4 and sine cube of 6 phi. So if 3 theta is phi, so 6 phi will become 2 phi and power cube over here. And then d theta is 1 by 3 integration with respect to phi. Again, still now the variable is from theta is changed to a new variable phi. So everywhere we want the angle as phi. So this can be done easily just by making use of the trigonometric formula. We know that sine 2 phi is equal to what? 2 times sine of phi cos phi. So that we will use over here. So what we have? Integral 0 to pi by 2 of cos raised to power 4 phi as it is. Then it is 2 sine phi cos phi cube and 1 by 3 integration with respect to phi. Okay, like this it is done. Now let's have the further simplification. So further simplification says that we have to collect the powers of sine and cosine so that we can apply this formula sine to the power p cos to the power q. Okay, so what it says, so it is so we have this as equal to, so I will now become 1 by 3 being constant, then 2 cube will be outside, 2 cube is 8, so we have 8 by 3. Okay, then integral from 0 to pi by 2, only the power of sine, so we have only sine cube of phi. Okay, so it is sine cube of phi and the power of cos need to be collected carefully. Here we have cos to the power 4 and here it is cos cube. So 4 plus 3 7. So we have cos to the power 7 phi. Integration with respect to phi. So now it's in the required form. Sine to the power p, cos to the power q. Variable of integration and angles in sine and cosine all are same. Limit is as per the requirement. So we can now apply the formula with p as 3 and q as 7. So according to the formula, what we get? P plus 1, p is 3. So 3 plus 1 by 2. Then gamma of q, q is 7 plus 1 by 2 upon 2 times, don't forget to write this 2. Many times students forget to write this 2. So 2 times gamma of p plus q. So 3 plus 7 p plus q plus 2 upon 2. Now just simplify and get the answer. So I think here this will get cancelled. So we have 4 by 3. Then this 3 plus 1, 4. 4 by 2, 2. And gamma of 2 is 1 factorial, right? Because 2 is a positive integer. So we know that gamma of n plus 1 is n factorial if n is a positive integer. Okay. Then 7 plus 1, 8. 8 by 2, 4. 4 is, gamma of 4 is 3 factorial. Upon what we have next here, 3 plus 7, 10. 10 plus 2, 12. 12 by 2, 6. 6 is, what is gamma of 6? That is 5 factorial. Now just simplify this. So finally what you will find, so here you will get the answer as, here 3 will get cancelled, right? What is left? 2. Any other cancellation? Is it possible? So here 5 factorial, from 5 factorial 2 will get cancelled and 4 will also get cancelled. 5 factorial means it's a 5 into 4 into 3 into 2 into 1. Out of that 2 and 4 will get cancelled, right? What is left? 5 and 3. So in the numerator we have 1 as well, and in the denominator I have 15. So like this the answer obtained is option number B, right? So just by making use of the result of the beta function, you can get the desired value. I hope this problem is clear to you all. So the new thing over here is how to convert a given integrals in a desired format. Okay, so here we have used the substitution 3 theta. Now let's move to the next question. The next question is the value of integral where a is greater than 1 is given by. So different options are given. looking at the options, you have to decide what should be the correct one, right? So see here, I have told you that you always have to observe whenever it's a case of the definite integral. So you have to always decide what is the variable of integration. So variable of integration is this with respect to which integration is done. So what is that? X. X is our variable of integration. Okay. So apart from X, you need to identify all other variables. So if you observe this integrand over here, so what we find another variable which is nothing but a. So here in that case, a is not called the variable. It is called as what? It is called the parameter, right? So here a is a parameter. So it's a general rule that you will integrate this with respect to x, and after integration you will apply the limit for x. So obviously x will get resolved. So only thing left after completing the process of integration is a. So finally we get the answer of this in the terms of a. So that is what considered as a function of a. So that's why the value of the integral is given by what? Function of that parameter. Okay. So what is that? F of a. Right. So correct option is option number C. Now let's have the next one. If f of a is this integral, then the value of integral df by dA. So here, as I said, the such integrals where we have a parameter and variable of integration, then it is denoted as a function of parameter. Okay. So here it is asked to find out the derivative of that. So what we do, we will differentiate both the sides, right, of this given expression. So we will differentiate both the sides, and as this integral is a function of variable of integration as well as parameter, means it is a function of two things. One is variable of integration and another is the parameter, right? So in such cases where integrand is a function of variable and the parameter, then in order to differentiate such integrals, we use the Leibniz rule. Again, based on the nature of limits of integration, that is whether it is a parameter or a function of parameter or a constant, we have two different rules. So rule number one, that is Leibniz rule 1, is applicable when both the limits are constant. So here, as both the limits of integration are constant, so we apply Leibniz rule 1. Now according to Leibniz rule 1, what we get, we have to write the derivative of integral as integral of partial derivative. Okay, this differentiation goes inside the integral and it becomes partial derivative. So partial derivative of rest of the things. So it is e raised to power minus x upon x, 1 minus e raised to power minus ax. Now let's go for differentiation partially with respect to x. So when I am differentiating partially with respect to a, then other is acting as constant, means terms of x is constant. So what it will be? So it is integral 0 to infinity e raised to power minus x is constant, then x is also constant. So only term differentiable is this. Again here, derivative of 1 with respect to a is 0 as it is a constant one. Now then derivative of e power minus ax. What is the derivative of e power minus ax? That is e power minus ax into, now be careful, we are differentiating with respect to a. So what will be derivative of this with respect to a? So that is minus x constant and derivative of a is 1. So in this way the differentiation is done. Okay. Now differentiation by Leibniz rule 1 is over. Simplify, you can find here, this becomes minus x into minus, so plus x, which will get cancelled. Okay, so we are left with integral 0 to infinity of e power minus x into e power minus ax. Now just apply law of indices. So as I said, used to say many times, whenever we have variable of integration with the the limits of integration as infinity, then we have to always write the form e raised to power minus of variable term. What is variable term? X and the rest of the things. So what will be left? 1 plus a, right, according to law of indices. Now integrate this. So it is e raised to power minus of a plus 1 times x upon minus of a plus 1 over the limit 0 to infinity. Now just apply the limit, put x as infinity, so it will take the form e raised to power minus infinity. And we know that e raised to power minus infinity is 0. Now put lower limit, x is 0, e raised to power 0 is 1. So minus of lower limit value, that is 1, upon minus of a plus 1. So what we get? We get this as 1 upon a plus 1. So that's how we get the correct answer for this particular problem is C. Now since I am explaining this problem, so you may find that it takes more than 5 to 10 minutes. It takes more than 5 minutes. But you are expected to answer this quickly, right? Because here I have written so many steps. So you just have to write from this first step directly this step, right? So that you will minimize the time consumed in solving the problems. Okay, so in this way it is expected to solve this particular question not more than 3 minutes. Okay, let's have the next question. The next question is again the same problem we have. So here it is given f of a as well as f of a is equal to some values are given where the constant of integration is obtained. So here this value is obtained by applying the Leibniz rule. So that value is mentioned here. So this is one and this is another value where we have to mention how the c is obtained, right? What should be the value of c by obtained by putting the values of a. So this we have to decide. So as I told you, irrespective of what the value given over here, you can decide in the first step, that is this step itself, what should be the value of a. So you have to choose the value of a in such a way that this integral must reduce to 0. Okay, so this must reduce to 0. So if I have f of a is equal to integral 0 to infinity of e raised to power minus x upon x into 1 minus e raised to power minus x. So just go for such value of a which will make this as 0. Again, the process of identifying the value of a to be selected is very simple. You have to go for first the limits of integration. Means first either put a as 0 or a as infinity. Most of the time it works. It will satisfy our requirement. Rarely it may be possibility that you have to go for some other values. Okay, so let's put say a as 0. If I'll put a as 0, I'll get e raised to power 0, which is 1. So 1 minus 1, so e raised to power 0, which is 1, right? So 1 minus 1 is equal to what we get? 0. So like this, just by putting a as 0, you will get the answer. Okay. So therefore, what is our correct answer? The correct answer is a equal to 0. Here it's wrongly mentioned. Okay. Again, the same question we have. X raised to power a minus 1 upon log x. Such type of function is given. And we have to find out what is the value of a. Answer is required over here. So let's see quickly how to do this. So as f of a is given, so we will differentiate this with respect to a being a parameter. So differentiate this with respect to a. Now derivative of integral is required, and as limits are constant, so we will apply Leibniz first rule. According to that, we write integral 0 to 1 of del a of the integrand, that is a x raised to power a minus 1 upon log x. This is by Leibniz first rule. Now differentiate with respect to a. So we have, it is in the form x is constant, x raised to it is in the form x a raised to x, right? If we will differentiate with respect to a, x. So the differentiation of x raised to a is x raised to a log x. Derivative of 1 is 0 upon log x. So this gets cancelled. We are left with simply x raised to power a. Integrate that. So we get the integration of x raised to a is x raised to a plus 1 upon a plus 1 over the limit 0 to 1. Now just apply the limit, put x as 1. So we have 1 raised to a plus 1. A is greater than 0. So obviously what it comes out to be 1. And when put x as 0, so it will become 0. So what we have? It's simply 1 upon a plus 1. Now what we want to obtain here, the value of a. So we will quickly differentiate after getting the derivative. We will integrate this. So on integrating we get, so integration of this derivative is function itself. So we have f of a is equal to, what is the integration of 1 upon a plus 1? Definitely integration is with respect to a. So what is the integration of 1 upon a plus 1? That is log of a plus 1 plus constant of integration. So this is our first equation always, right? And this is second equation. Now we have to choose the proper value of c, which will make this as 0. So what should be the value of c? Parameter c, a, in order to obtain the value of c. So here I have to choose the value of a in such a way that this reduces to 0. So let's take, say, lower limit. If I take lower limit a as 0, so x to the power 0, 1. 1 minus 1, what we get? 0. So a equal to 0 gives you the correct answer for c. So put a equal to 0 in equation number 1 and 2. So we get 1 implies f of 0 is 0 and 2 implies f of 0. A we are putting as 0. So a 0, log of 1 is again 0. So plus c. So just combine 3 and 4. You will get what? Equating right hand side, you will get c as 0. So put this over here. So equation 2 gives you the final answer. What is that? F of a is equal to log of a plus 1. C is 0. So what is our final answer? Final answer is given by option number C. So this is how the problem is solved. Now let's have the next question. So this question is related to the previous one. So I would like to utilize that. So in the previous portion we have seen that f of a is log of a plus 1. Okay. And here in this example, what it is asked, f of 0 is asked, right? So as I know, f of a is log of a plus 1. Okay. So how will you get f of 0? So just put a equal to 0 over here. So put a equal to 0. What we get? Log of 1. And log of 1 is nothing but equal to what? 0. So f of 0 is what? So answer is option number A. F of A is 0. Right? So in this way, the possible question on differentiation under integral sign have been covered. So in the next video lecture, we shall see the few more important questions on the same topic as well as theta and gamma function. Thank you all for joining the class.